Okay, Assalamualaikum and good afternoon. Moving to the third subtopic, which is on the general motion. Okay, here we have a picture of a jump jet or VTOL aircraft, okay, vertical takeoff aircraft. Okay, once a safe speed of descent for a vertical landing is reached, a Harrier jet, okay, a Harrier jet pilot will adjust the vertical thruster to equal the weight of the aircraft. The plane then travels at a constant velocity downwards. Okay, here mentioned constant velocity downwards. If motion is in a straight line, it is what we call uniform rectilinear motion. Okay, for a particle in uniform rectilinear motion, the acceleration is zero. Okay, why? Because the velocity is constant. Okay, there is no change in the velocity. Okay, therefore the acceleration is zero. Okay, here is the mathematical expression of this condition, where we have a change of distance because it's going down. Okay, depend on the time as it's go down. However, the speed is same, so it is constant. So if you want to analyze this particular problem, you want to, let's say you want to find the what's its instant position, you can use this formula to get that okay position by simply do this math. Okay, therefore you will arrive with x equal to x naught plus vt. X is the final position that you are looking at. That's depend on the t, and x naught is the initial position that you analyze. Okay, moving on. For a particle in uniformly accelerated rectilinear motion, the acceleration of the particle is constant. Okay, you may recognize this constant acceleration equation from your physics courses. dv dt is equal to a. In this case, a we consider as a constant, and if you would like to know what's the velocity at that particular instant, you can use this formula. Okay. Similarly, if you would like to know more about the position, again, here dx dt is previously you only deal with dx dt is equal to v because v is constant, but in this case, because we have a, which means that v is no longer constant. Okay, that's why we have another term, second term here, at, which is another speed. Okay, so we can replace this dx dt into this formula v here. Okay, so then you do the math, then you will write this expression, long expression like this. And this one, if you would like to analyze it with respect to this one with respect to time, and this one with respect to the position itself, then you will arrive this to this particular formulation. Okay. Careful, this only apply to uniformly accelerated rectilinear motion for this part. Okay, if let's say the acceleration is changing, the acceleration is initially it is 2 meter per second square, and later on it changed to 3 meter per second square, and therefore this particular procedure will not valid. Okay, for particle moving along the same line, time should be recorded for the same starting instant, and displacement should be measured from the same origin in the same direction. Okay, referring to this on the left, where you start at point O, then move to the point A, and then point B. So you have the particle, the red dot here is represent the particle that is moved from point O to point A, where we have XA, and then from point A to point B, we have XB slash A. What does it mean actually? Okay, B slash A means B with respect to A, because before this particular dot reach, this red dot reach at point B, it start from point A. Okay, so that's why we say that from here to here, we call it XB. Sorry, the position X from B with respect to point A. Okay, and the total, the distance from O to B, we can say it is a XB lah. Okay, so this is how we write it in the mathematical form, where XB with respect to point A, this is equal to XB minus XA. Okay, or you can also say that XB, okay, XB is equal to XA plus XB with respect to A. Okay, and the rest is follow for velocity and also acceleration. Okay, the same procedure. Okay, thank you.